Welcome, everyone, to our podcast today, and welcome everyone back. My name's Andrew Bodden. I'm your host here for this podcast, and right now we've got some serious issues with heat in the fields. Pretty much everywhere there's corn, we've got heat issues. And I'm joined today with Andrew Penny, who's the agronomy lead for PRECEON for Bear Crop Science. So, Andrew, introduce yourself.
Yeah, thanks for having me, Andrew. So my name's Andrew Penny. I am the agronomy lead here in the U.S. for PRECEON, for Bear Crop Science. And so PRECEON is our trait, our germ, for our short corn. And so as we continue to launch and build the PRECEON name, we have a lot of growers across the U.S. Excited for short corn.
Yeah. So let's talk about this heat issues that we have right now, pretty much across the Midwest, but anywhere there's corn, we've got in North America, we got heat going. And tell us a little bit about kind of what corn sweat is all about and how it impacts on the short corn.
Yeah, absolutely. That's a good question, Andrew. So this is a topic that gets brought up every year. We often hear about corn sweat across the corn belt. Anywhere there's a large number of acres of corn growing, and it's really turning the term transpiration and changing that up into corn sweat. And so whenever I talk about this, I kind of like to break it into three different parts or three different terms, and that's evaporation, which we're all probably familiar with. And we have evaporation that occurs from the soil surface, throughout the early part of the growing season. So when corn plants are small, or even soybean plants are small, we have more evaporation that occurs from the soil surface than what the plants would lose through their leaves. And so that kind of walks us into the second term that I like to use, actually that we use in the science community to discuss and give meaning to how plants move water from their roots out into the atmosphere. And that's transpiration. And so we have evaporation that occurs through the soil surface, and then we have transpiration, which describes the movement of water from the roots out to the leaf. And so then we have the third term that kind of combines those, and that's evapotranspiration. And so that occurs, as plants get bigger, the transpiration rates exceed the evaporation rates, right? The more soil surface we have exposed, the more is going to evaporate. But then as plants get bigger, transpiration rates are higher than what So then when we combine those terms, that's the combination of the amount of water lost to the atmosphere from the soil and in the leaves. And so that's evapotranspiration. And how all this kind of plays together in the term corn sweat is when temperatures increase, and like what we're seeing, warmer temperatures, plants can't move away or go under shade like humans, right? So plants need a way not only to bring water up to, bring water nutrients up to maintain their needs, but they also need to cool themselves. And so, humans sweat, right? Plants don't sweat. And so transpiration and the movement of water from the roots to the leaves and that evaporation on the leaf surface is how plants cool themselves. And so we often use the term corn sweat because there is, moisture moving from the soil profile out into the atmosphere that can add to humidity or what we feel, right, in the air. And so, I think corn sweat often gets a bad rap, or maybe gets blamed for a good majority of the moisture and humidity that we're feeling in the air. It kind of makes it muggy, almost feels like you can walk outside and just cut the air with a butter knife. But in all reality, that a good majority of a lot of the moisture that we're feeling in the air is probably more likely coming from, wind currents like from the Gulf of Mexico, bringing warm, humid air up. So, and I think of, when I think of transpiration or evaporation, that especially transpiration, that really tells me that we have a healthy plant that's moving water, nutrients up, from the soil surface to the leaves to not only cool itself, but also there's a gas exchange, right? So anytime you have transpiration occurring, the stomates on the leaves are open, and we have CO2 gas coming in, and also the moisture leaving the leaves, leaving the leaf and sitting on the leaf surface to cool the plant. And so it's really a good thing that it's occurring, that healthy plants transpire. And so this whole leaf sweat thing, it is a thing, but it probably contributes to a much smaller amount than what the wind currents do.
Yeah. So when you talk about that, obviously it's really important that the plants do this process. What's the benefits of it? Especially when you've got such heat right now, obviously.
Yeah. Yeah.
If you look at the human side of things, if you overheat, that becomes an issue. So when we
Yeah.
got so much heat, how does the plant react to this? Is it a positive thing? What are the other impacts of these type of the corn sweat? From root structure to stalk structure, all that stuff.
Yeah. So no, that's a really good question. So as I mentioned, plants can't go find shade on a hot day, and so the one thing the what we know is as temperatures increase, the air can hold more moisture. And so when you look at the vapor pressure deficit or the humidity, how much moisture is in the air versus how much moisture the air can hold, as temperatures increase, that same air temperature can hold more moisture than if it was 10 or 15 degrees cooler. Right. So the impact and the importance of transpiration in the plant being able to move that water from the root system to the leaves is critical, because if plants couldn't cool themselves, the cells on that leaf tissue would be impacted. Just like we could overheat, the plant needs to maintain and tries to maintain a temperature that doesn't impact cellular health. And so with that too, we have respiration that occurs in plants. And so that's the process of converting those sugars that the plant makes through photosynthesis into energy that plant can use. And so as temperatures increase, those respiration rates in the plant cells increase as well. And so all this kind of works together. But at the end of the day, that process of moving water from the roots to the leaves is critical, so that plant can continue to function properly under high temperatures but without cellular damage.
Okay. Obviously, one of the things we were going to talk about today is kind of what does bear crop science have kind of that's going to help when we have these great heat issues, and what can protect what exists that you have to offer to protect the corn plant from traditional products to what you have now.
Yeah, that's a good question. Probably the biggest thing we've seen, you look back on corn breeding over the last 20 to 30, I mean, 50 years, right? The impact that breeding has had on plants across crops, but especially corn, to tolerate different environmental conditions, from, different diseases, weather conditions, heat and drought, which usually accompany each other. It has a huge impact on the yield potential and the ability for growers to continue to raise a crop under these a little bit harsher conditions. So there's really nothing that, other than breeding, there's no magic wand that we can do to make plants tolerate these conditions. But breeding is something that absolutely helps, and having such a phenomenal breeding program at Bear Crop Science, focused on corn among other crops. That's the critical piece. It's understanding the environmental conditions that we face, whether it's in increased temperatures, the CO2 concentrations in the atmosphere, diseases. We can breed for that stuff, and as we release those products, they're better able to tolerate those conditions.
Sorry, that leads us into kind of the PRECEON Smart Corn. Like, tell us about how that is unique in its manner.
Yeah, that's another great question. I mean, just like we have heat and drought, different stresses that the globe can experience, right? We have a lot of wind damage, and so with a lot of these storms, a lot of these harsher environmental conditions that we've faced, all corn products run the risk of either green snap or root lodging, and so when that occurs, that makes it really hard for the grower to harvest, and sometimes if it's green snapping, there can be a pretty large yield loss because you're not able to capture that year. And so one of the biggest benefits of short corn, our PRECEON short corn system, is the ability for that plant to withstand wind. And so not only is it going to help growers and the dealers that sell the products reduce their risk for wind damage, but it's also going to allow, because of that shorter stature, I think more importantly, it's going to allow us to have conversations about how to be more efficient with our nutrients we apply, right? And so the more we can start having those conversations about nutrient use efficiency, when do we apply nutrients? When does the plant actually need them? How can we increase the ROI for every pound of whatever nutrient we put on for growers? Because of that access piece with short corn, I think that's going to be the bigger piece.
Okay. So just kind of, we've talked about kind of the issues. Is there anything else that we should know that, that the growers should know about what to best manage for corn sweat? Does the PRECEON Smart Corn make sense to put into rotation depending on geography and all the other environmental issues?
Yeah, no, I think that, if we're talking about corn sweat specifically, I think at the end of the day, it's good to remember, through evaporation, through transpiration, and then the combination of evapotranspiration, there is some moisture that's added to the atmosphere, but in all reality, it's a small percentage compared to, what the wind currents bring up from, different parts of the warmer regions. And so, as we think about, the whether this is good or bad, it's obviously a good process, right? We need plants to cool themselves so they can continue to function, and it's a very small percentage, compared to wind currents from the Gulf of Mexico, let's say. In terms of thinking about how to incorporate PRECEON in short corn, anywhere there's potential drought case scenarios, and anywhere we want the potential for a bigger root system to explore soil and explore that soil for water nutrients, or there's any risk for wind damage, PRECEON short corn is going to have a huge impact on that risk that growers could potentially face for those scenarios.
Is there any data that you can share with us as far as any side by side where there isn't been PRECEON Smart Corn, the shorter versus any other genetics to see the impact? I know it's going to be hard because it's geographically focused, but any
Yeah,
data you can share with us?
yeah, we have a lot of data both internally and also at our, the universities that we've partnered with, looking at the reduction in wind damage. That's very consistent. That data is well proven, and we have a lot of data that shows, just how much we can reduce green snap or root lodging in those scenarios. It's not perfect, but it's drastically different and much better than our traditional tall corn hybrids at withstanding higher winds. In terms of looking at how we think about and explore the root system, we see a little bit different root system in short corn compared to tall corn. We see both in our internal and external trials with university partners, we see a little bit bigger root mass and a little bit bigger, quicker growth early in the growing season. And so as we talk about populations, populations can decrease the overall root mass. Higher populations can decrease that overall root mass on a corn plant. And so we're looking at and trying to give some data behind what does that mean for growers. If you're under irrigation, if you're under some soil textures and soil types that might be a little bit lower in organic matter, lower nutrient content, what does that look like? Does that bigger, quicker root mass that occurs early in the growing season, does that help that plant explore more soil and potentially find some of that water and nutrients?
Wow, that's a very positive data that you've got to share. I appreciate that, and we'll try to integrate some of that into the interview. Is there anything else you wanted to touch on, Andrew, before we say goodbye?
No, good question. I think we covered evapotranspiration and the two components that make that. So I think at the end of the day, if we can get it, does nobody likes humidity, right? When you're walking out there and you just feel the air, but the corn across the Midwest is a small part of that, but a very important piece for plants in general to maintain healthy cells under these hot conditions when trees, shrubs, and no plant can go find shade under these dreadfully hot days.
Yeah, perfect. All right. Well, thank you again for your time, Andrew. Really appreciate it. And on behalf of myself, Andrew Bodden, thanks for everyone for joining us today, and we'll see you soon. Goodbye.
Thank you, Andrew.